Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
It's my great pleasure to have Gilad Bracha here today. And most of you know Gilad, and so I'm not going to talk a lot about all the things he's done in the past, but most recently he's been at Cadence, before that at Sun, working on Java. And today he's going to talk to us about Newspeak and the brave new world that will engender.
Thank you. So thank you. Good morning. Thank you all for coming. Well, from all the topics I proposed, he said I should give a general audience kind of talk. So this is kind of a big, high-level overview of the motivation and kind of the things I've been doing in the past few years, and probably not enough time to go into a great amount of detail on every one of these topics. So what are we talking about here? What is this idea of full-service computing and this brave new world? Basically, the good news is that personal computing is still alive, but it is changing in a big way. And that's driven by the fact that software isn't really being distributed as an artifact anymore, but more as a service. And this software as a service, right, this is kind of the vague kind of vaporware that people talk about, but I hope to actually make this relatively concrete and show what the implications of that are as we go along. Basically, when software is an artifact, something you buy, you used to buy it in a store in a big box with lots of paper around it and shrink wrap and stuff, and it's yours and you're supposed to care and feed for it. It's like a goldfish, and you need to service it yourself. And when it's a service, well, there's a service that can handle all that things. And what that realistically means that you move away from self-service computing, which is what we've had for 30 years, where all the chores involved in maintaining your software are your responsibility as the user. So things like installing your software, and then uninstalling it, and then installing your viruses, which you don't really mean to do, but the process is such that you will, because you have unlimited access to the file system and you don't know what you're doing. I mean, not you, not us, of course, but the masses out there, right? The people who actually get a computer to do something useful for themselves, not just to play with it. And of course, then you have to uninstall your viruses. And then you want to upgrade your software. And then you want to downgrade it back again when it doesn't work. Right? And on these machines in particular, they don't like you to ever move back. So, which is a theme here as well in this talk, but it isn't necessarily easy. And you have to back up your data, right? Does your grandmother back up her data frequently? I don't know. Mine doesn't. Well, she doesn't do anything, but she never would. My mother doesn't back up her data either. And then, of course, you restore your data, right? Because the whole reason you back up your data is you know that your software is going to let you down and trash your data. And so, of course, you eventually have to restore it. And all of this is a great deal of fun. And the vast, vast majority of people using computers, including actually people who know a lot about computers, don't necessarily want to do all this. Most of them can't. They're not qualified. They don't even know they have to do some of these things. And so getting rid of this self-service model is a good thing. In full-service computing, basically the service manages all this stuff for you, right? And we're moving toward a world like that. And what that means, of course, the user has less responsibility, and people love getting away from their responsibilities. But on the other hand, they have less control. And it turns out most people don't seem to mind. It's only the developers, the people who love to play with computers for their own sakes, who seem to mind. But that includes me, so it's important that we overcome this problem. So there's many signs of this coming, and some of them have been around for a while, right? Obviously, web applications, right, are a start on that, right? With web applications, you get the thing on your web page, and And you don't have to install it or uninstall it or deal with it. And I just wanted to put up this quote because it is interesting in a historical context, right? This is from 1995. And the nice thing about it, it all tells you how you can update your data and everything over the web and so forth. And you were supposed to use this with HotJava, which is the original web browser that Sun had as part of the Java project, the one that didn't work because of AWT and various issues. But especially, the bottom line is, right, there is no upgrade problem. I worked at Sun for 10 years in JavaSoft. That line stuck in my mind. But this is really where the vision is, and to some extent with these web apps, with these pure web apps, that's true. It just doesn't happen to be Java, it happens to be JavaScript, but the concept there was actually very visionary. The thing is, web apps, have limitations. You can't actually have a web browser be a web app, you can't have all its plugins, codecs, etc., the operating system, lots of things can't be web apps. UI issues we've made a lot of progress on, but still things keep evolving, right? The reason that the App Store prospers is because, a native app is still so much better than a web app on these phones, for example. But fundamentally, right, a web app depends on the network being there, on the web being available. There's Wolfram, I think, wondering whether he should come in. We saw you. You want a network that's there, that's reliable, that's fast, and that's cheap, right? And those three conditions, don't happen at most airports, for example, or on airplanes, or in all kinds of places. So that's an issue with web apps. The other harbinger, which is tightly linked to the first, is, of course, cloud, right? Things like Azure and Amazon Web Services and so forth, right? Of course, these things are there to enable these web apps, but they mean that you no longer have to build all this infrastructure yourself to back them, right? That there's essentially turnkey services you can use to making it much easier for people to actually materialize these services. Okay, so all of these things are coming. But of course, the cloud, the same issues come up with respect that the cloud isn't supposed to be just time sharing, right? I mean, sometimes it sounds like it's just, time sharing is an old phrase from the 60s and 70s. We need to reinvent and give it a nice, sexy name, so we call it cloud computing. But there is the issue of offline use. There is the issue that basically you are wasting enormous amounts of computing power. All these devices at the edge of the network, what are they doing? Right? And you can say, well, we don't care, right? The other advantages of the model are such that, yeah, we just do all this stuff in the cloud, and these are just, dumb terminals in some sense. But there are reasons, there are actually economic drivers why there's a problem with this model. Because that means, if you can turn over more of if you can utilize that capacity at the edge, you have an advantage. You don't have to have as much computing power in your data center. You don't have to waste as much energy in your data center. So there are reasons why it actually makes sense to use the devices that are out there, all the various devices. Which brings us, of course, to the third step in this, which is mobile devices. And this is Big Brother's eye, by the way, which is the Newspeak logo. And unfortunately, beyond getting the PDF of the logo, it doesn't seem that I'll be able to get it to run there because you're probably aware of the issues, and we'll probably touch on them. But these devices really have been a major, and still are a major driver of this trend toward full-service computing, right? Starting, well, we'll get to that, right? Why are they a major driver? Because of originally the phone services, right? They naturally are services. And they very much wanted to keep you in an enclosed service of their own. And anyone who's followed this and remembers things like Brew and various tools that were designed to supposedly support app stores of some, before they were called app stores on phone networks, knows that this was the intent. These things generally failed because, of course, they had no attractive software to run on them. And that's because, to make this model work, a software as a service, you have to know something about software, which is why the people who will dominate this are the software industries, people like you, people like Google, and not the telcos, the pipes. They don't want to be pipes, but that's all they know how to do. So they try to be software, and All of you probably got junk mail from AT&T at one point offering you some bizarre and useless enclosed garden of some, or enclosed desert really is the problem, right? Because nothing grows there. So of course, the latest stage in this evolution is the iPad, and what this is driving us is toward a model of a service, right? The App Store is a service, right? They sell you an app supposedly as an artifact, but in fact, what you're really buying with the iPhone is the service. The fact that all these apps are actually being updated. In fact, when you buy for $2 an app on the iPhone, it usually is continuously updated. You get free updates all the time. They don't generally charge you for upgrades, right? It isn't as transparent as one wants, but that's what's happening, right? And the promise of this is really this full service model where you don't have to worry about viruses and backup and all that, and someone is going to take care of this. So this is the idea of, leads us to this notion of a networked service application, which combines these advantages of web services and of traditional clients. So it's always available. It's available offline without a network. But it's always up to date, at least, as long as there is a network. But it combines the advantages of being local on your client and of being globally connected. So for example, it has full access to whatever local capabilities you have, things like the GPS, the camera, things that might be difficult to do in a web app on a mobile device, and in fact are made deliberately difficult. They don't actually have to be difficult, but there are strong interests at stake here. And I would like to emphasize this point. This is my pet peeve in the world. I don't like things that reboot. I never really liked it when computers rebooted, and as we go digital, now my television reboots, my phone reboots. That's particularly annoying. You don't want your phone to reboot, right? It's supposed to be there for you. And so maintaining this without this continuous service, without having to worry about restarts as it updates is one of the goals of this work. So what does this service do? Well, it does the digital housekeeping, as we said. It does backup, audit trail. It is the means how you distribute your software and how you update it, how you maintain it, bug fixes, new features, whatever. And the way we're going to do that is essentially very much like the way you synchronize, say, a calendar or an address book. You're basically going to synchronize your data and your program with the server, right? And then your client should be able to run offline with the cached versions of these things. That doesn't work for all scenarios. There's massive amounts of data in small devices, but those are variants we could get into detail later. In fact, Manuel and I just started talking about that. The important thing is that this synchronization does not imply stopping everything and starting again. Right? Otherwise, well, that's an interesting possibility, but I'm trying to avoid that. So, being a language and platform sort of guy, if all you have is a hammer, obviously you look for the platform and language support for these things, because how else would you ever solve a problem without a language? You're nothing. Done some work on this language Newspeak that has various interesting properties. I mean, it turns out it has interesting properties outside this context, but the aim of this talk is actually to tie these two threads together and show how these things relate, because this vision of network service applications has been behind the scenes driving Newspeak all along. So we want to make it easier to build these kind of applications, and a platform that will support that. And the inspiration comes from a bunch of work in the classic dynamic languages, the Lisps, the Smalltalks, the Self, etc. So in particular, what do I view as interesting areas where we can contribute in this? There's hot swapping. Hot swapping is just a concise term for reflective program update, right? The ability to actually change a running program while it's running and to modify it, which would in this context means we can update your application for you and introduce new code, new features, bug fixes, whatever, without forcing you to stop everything you're doing, right? So the fundamental ability to do this has been around for a long time. And it goes back to, to give it a really ugly name, right? Think of some assembly language routine stepping on itself, right? So this is, this makes people nervous, and rightly so, of course. There are lots of real issues, and there are more imaginary issues. So we're talking about having imagine a client application that's running, and you press sync, and now your application is updated, but you didn't have to stop it. You didn't get a little window saying, you're still running this app, please shut it down before we can do the update, all the kind of stuff that you see today. So there's a question of, okay, I'm doing that, and what if some of the code that I'm modifying is actually code that is actually still running on the stack, right? It's not just sitting there in the application, but it's actually, there are stack frames that are tied to this, right? That's a particularly nasty question. There's all these issues around schema changes. Well, my data, we change the shape of the data. What happens to all the instances of existing objects, et cetera, et cetera? What happens to their representation invariants that they might have had that the new code has different invariants? And there's, some people fuss about security too. They get nervous about these things. So generally, we need some sort of structure to handle this. This all depends ultimately on what your reflective API can do. And we're not talking about a reflective API that just introspects, as mainstream tools do. We're talking about the ability to actually change what the program is doing on the fly. Right? This is what makes dynamic language dynamic. Right? I don't like this phrase dynamic languages, because if a language isn't dynamic, it's dead. Hieroglyphics is a perfect example of a static language. It hasn't changed in a long, long time. It's very stable over time. But any language that's being used is always dynamic. The term dynamic language refers instead to the programs written in those languages. Those are the things that are dynamic in the sense that the program definition itself evolves while the program is running. Right? That's what we want to do this in a structured way. And the answer is going to be a thing called mirror-based reflection, which I'll talk a little bit more about shortly. And there's a paper in UPSLA 2004 for anyone who wants to dive deeply into this, and there's a talk on the web and so forth. Now, it turns out that this whole problem gets a lot easier if you can restrict it to what I'll call a situation where the program is quiescent. And that doesn't mean shut it down and start it up again. So what does it mean for a program to be quiescent? Well, in this context, it turns out that all these apps that do synchronization, right, when you're actually synchronizing, from my perspective, they are quiescent. The only thing that's going on at that time is the synchronization. No user tasks that, something the user asked the application to do are happening. You're at the bottom of the event loop, right? So you don't have to worry about that stack being changed, because really there is no stack. You're at the bottom of the application. So it turns out that for the purposes of this kind of scenario, the synchronization is exactly the kind of place where we can define away the nastiest problem about this reflective update. And of course, we'll synchronize our program and our app with a server. By the way, it doesn't need to be a server. It's easiest to think about this in the client-server context, but this can be done peer-to-peer. Right? That when you do it peer-to-peer, it turns out to look very much like distributed source control, except instead of files, you're dealing with objects in an object database. And of course, if you're doing this allows all the things that you want for various, you would like to have your stuff backed up on this server. You'd like to be able to go back in time and audit what's there. You'd like to get it from your phone and from your laptop and from whatever, right? And you'd like multiple people to get at it so they can collaborate. All these scenarios fit quite well in this scene. So it seems to be a useful thing to do. So the synchronization, as I said, is a natural point to do this program update because of the quiescence. It also has another advantage, is that this isn't completely transparent to the user. I argue you don't want it to be totally transparent, because something's going to change afterwards. So if you synchronize your calendar and you click the button and say synchronize, you're not surprised when new appointments show up. By the same token, you won't be surprised if there's a new menu item with a new feature, or the look of the application has been tweaked, or whatever, a bug has been fixed, right? It's been updated. You know it's been updated. On the other hand, it has been updated in a very lightweight way, right? Maybe you just click a button. Maybe you actually say that it will do this, hourly or something, as long as there's nothing going on, which in most client applications, nothing is going on most of the time, right? Because humans are slow. And of course, the key thing is this concept of program as data, right? We're going to be syncing both of these by the same mechanism. Which brings us to this idea of support for synchronization, in particular what I call orthogonal synchronization. So the idea is that we're going to have a sense of that some data is persistent, and that data is going to be synced every time. What's persistent is persistent by reachability. So this will remind people of orthogonal persistence, and we'll shortly explain why it doesn't have the same problems that orthogonal persistence had. Right? But basically there's a set of persistent roots, and anything that's reachable from there is persistent, except if it's marked transient, which again is a trick from the orthogonal persistence guys. And what do we do with the transient data? We recompute it after every sync, because it's dependent on the fundamental data is the persistent data. The transient things are useful, things that were computed and cached, but they depend on that data, and they have to be redone if the sync has changed something. And there are ways to do this either with language constructs. You can imagine declaring certain slots or fields transient. There are several schemes that we've considered doing with this, and then there'd be like a closure here that told you how to compute what the value was. So of course there's, orthogonal persistence is an idea that went out of fashion, and because there were issues with it. And of course, any criticism of that does not apply to this idea. Now, the main criticisms are that data outlives the program, for example, right? So you have this application that was written on some old computer with some old processor and an old compiler, and it's in the only version that works is in the computer museum somewhere. But you have these valuable tapes of priceless data, treasure maps and stuff. And now there's no way, because they were spit out by your orthogonally persistent Fortran program, there's no way now to get at them. So this is a problem with orthogonal persistence. This is not a problem here because program and data co-evolve. There's no such thing as data separated from the program, right? They're as long as the service is up and running, these two are together. This is also a very object-oriented way of thinking in the sense that you tie the behavior and the raw data together. Now, another argument is, transient data, things that isn't really part of, say, what people often call business objects, right? That's polluting your data because this is stuff that was just necessary for your program to use. And this is actually something the orthogonal persistence people really addressed, and essentially the transient data doesn't get synced. In fact, it gets zapped at every sync. And then there's the complaint about no cross-program data interchange format, right? If the data is tailored to a particular program or application, instead of going out in some standard format that everybody can read, then it's locked inside the silo per application. Well, guess what? In this service world, we're beginning to see that that's exactly what is happening. In the sense that things have to. It's a distributed world, and things don't have access to a file system. There is no file system. What you have access is maybe a key value store. Maybe you send out XML through some stream. If you want to talk to some other application, you're going to have to explicitly go through and put your data in that form. So altogether, I'd argue that these things that really did kill orthogonal persistence don't apply here because we're really, the service is taking care of this. So how do we do it? That's an interesting question. Do we do it? Well, we have prototypes, right? Very early prototypes that did this. And the basic strategy was, because we control the VM, what happens is that there's a bit in the object header that we found free, and it's a shallow immutability bit. And persistent objects are marked immutable initially, and when you try to mutate them, the VM traps. What you do then is you actually unset the bit and let people, mutate them at will. The point is that you've had this, on this occasion, you make a note that this object has changed, which means that you have a record of what has changed, which you can use to build up an efficient efficient representation of the changes that you can send over to your server or other peer. So that's the basic idea of the mechanism that we use. There are other mechanisms one can imagine. We start out with a mechanism where we simply changed classes of objects and stuff like that. Again, it's a very dynamic setting. If you don't have that, there are various games you can play, but that's how we're doing it. And this part, the implementation has not gone very far, but we have done experiments where this works. So to summarize this up to this point, what we're doing and why languages play into this is we want to achieve this kind of software service. And the approach we're taking is based on orthogonal synchronization of programs and data. To synchronize the programs, we need hot swapping. We're actually modifying live programs. And to do that, it's very useful to have a dynamically typed language. It is possible, in principle, to do this with a statically typed language. That is an excellent research topic. There are a handful of papers. There's nothing real, as far as I know, that really, really works that's out there. Every now and then someone publishes a paper about it. On the other hand, almost every dynamically typed language does this, which tells you that it's way, way easier to do it in a dynamically typed setting. And since headbanging is not my favorite sport, we decided to not necessarily make life more difficult than it already is in that respect. So dynamic typing is an enabler for this whole sequence of things. So then there's this little issue of security, right? And our story over security is what's called the object capability model, which hopefully I'll explain in a few slides for those who aren't familiar with it. But the issues with security, there are lots of them, right? Basically, the whole, again, this goes back to the idea that this hot swapping and transferring programs over the network is suspect, especially this kind of hot swapping. So, of course, you don't want fake servers pretending to be your server and corrupting your client, and you don't want fake clients going and corrupting the server and thereby corrupting all the clients. But this is actually a problem that people have dealt with. I actually don't know how well they deal with it, but this is standard, right? Operating system updates happen this way. Antivirus software updates this way. The App Store updates this way. The App Store. Apple's App Store. There are others, right? But there is one true App Store, right? So that, let's assume this can be dealt with. I still argue you need a strong security model for your code. And you could question this in this scenario, because you say, well, now I've got this reliable service that does all these wonderful things. I mean, it isn't the open internet where I'm downloading code from the Russian mafia or something, right? The Big Brother is looking after me here, right? And I still argue, so basically their argument is this, right? We don't need the language to muck around with security. We have Objective-C and all is well. So Objective-C isn't good enough, partly because the question is, okay, so what you're saying here is that the server is taking care of this, the service, right? How does the service take care of this? How does it, in fact, ensure that nothing bad happens? Well, Apple tends to eyeball every app and come up with random results, whether it likes them or not. But that really isn't a very good solution. Put another way, here's another question for you, right? What is the relationship between programming languages and pornography? Well, there isn't much literature on this, but it turns out that the relationship is also true of cross-compilers. That's a later discovery. And what do these three things share in common? They're part of an unholy trinity, that they're all banned at the App Store. And why are they banned? Well, they're banned essentially to preserve the integrity of the service. That's a label you can put to all the various motivations that there are there, right? Because once you open it up to these tools, they're very powerful tools, and all kinds of things can happen. And the easiest thing is to just say no, right? Integrity of the service means integrity of the user experience, which is what people like to talk about publicly. So security, stability, performance, things that might undermine that. But of course, it also is integrity of the business model, right? If we are running such a service, we don't want a meta app store that is a Trojan horse riding on top of ours. I'd say that that last one is actually fairly easily dealt with by legalistic means, terms of service and stuff. You can, if someone is collecting money, you can find out and deal with that. Actual app security and data security is something that you cannot leave to the lawyers, obviously. I mean, that's, the cats and milk. But we really do need a code model, something that does this. And I am not inclined to the typed assembly verification code model. I have spent a lot of my time with the Java verifier, and I must say that I do not really believe in that approach. And it would be an entirely separate talk just to go through the various things that why that is so. But I do believe that you want a dynamically type-safe and pointer-safe wire format. And the nice thing about that is that's a matter of context-free syntax of the wire format. And context-free syntax is one of the very few things in computing that people actually understand. So that's one thing. Another thing I'd argue is we want strongly encapsulated objects, because we are going to use this object capability model. And what is the story of that model, right? The idea here is that security is based not on checking permissions, right? If you have, let's say you throw a party and you're dishing out lots of caviar and foie gras and good stuff, and you don't want big gate crashers. So you could put a bouncer at the door, and the bouncer can do one of two things, right? They can check a list of who's invited, and that's sort of the classical approach of access control. Or they can just assume that if you have an invitation, you can get in, and if you don't, the bearer of an invitation can get in. That's a capability, right? So object capabilities are the same idea. Basically, you can do anything you want if you can get away with it, if you have an object that will know how to do it. Or if you can get such an object, if you have an object that will hand you another object transitively. If from your application there is a way to reach by access, by whatever means of access your language has, preferably method calls, or to reach an object that knows how to do something, then you can do it. And if you don't have a way to reach this object, there's no way on earth that you can do it. But to do this, you need to be able to encapsulate these capabilities in some way. And say in JavaScript, they can sort of, or in other languages, you can get away with putting stuff in closures, right? Because procedural abstraction is the only real abstraction there is there. And in fact, object encapsulation is procedural abstraction if you ever look at the semantics, the formal semantics. But it is much more comfortable and easy to model if explicitly, you can rely on an object encapsulating something. Not a class encapsulating something, an object encapsulating something. So this is a language feature we're going to be after. And in particular, once we have these capabilities, this nasty issue of reconciling reflection and reflective update and hot swapping with security, at least we have what I think is a plausible approach to deal with it, right? Generally, the classic way that reflective APIs are structured means that, if you have, say, in the languages that support this, the Lisps, the Smalltalks, etc., you get an object. Well, gee, you ask for its class, then you tell the class to change itself, and now you've not only corrupted that object, but as a bonus, you have corrupted all other instances of that class all over the world. Neat. Kind of hard to argue for security in that scenario. However, with mirrors, the object itself does not bear that capability. The capability is a separate object called a mirror that reflects the object. And therefore, you can control who has access to mirrors. You can make, in this framework, you can make programs that act like Fortran programs that can't reflect on anything. You can make things that act like Smalltalk programs that can do anything they want, and you can do all kinds of things that are plausible in the middle. For example, you may only introspect on public APIs. Or you can only modify yourself, your object, but nothing else, not the class, not other objects. There's all kinds of, and there's a interesting agenda of research of really nailing this down and proving that this works and building APIs around this, which we're just sort of started on. In any case, you can't do it with a traditional reflective API, and you certainly can't do it with a scripting language where there's simply no reflective API. It's kind of, catch as catch can. So this all implies, by the way, some sort of sandbox approach. The object capability model requires that capabilities be passed explicitly, that there aren't ambient capabilities in the environment. A typical example being, say, file. Right? If you have a global name that gives you the file class, and the file class gives you instances that can take a string and open a file, that is an ambient capability that everyone can get at, and then you have to start implementing things to chase them and try and find out who's doing that. We don't want that. So in fact, Newspeak has no global namespace at all. And this is something that many people find a little puzzling, how that works. And I don't know, this talk, if people are interested after the talk, I can show you how that works. So again, a little bit of take a break and summarize where we are. Again, the hot swapping is an enabler for the software services. So apart from the dynamic typing, we also want it to be secure. And an enabler for the security is object-based encapsulation. So these things get easier in certain... If you have a language where you don't have these structures, well, it's probably still doable. It's just going to be so hard. So we're trying to build a system where we can experiment and develop these ideas without struggling with a lot of difficult issues that shouldn't be there. And then we find that there's this issue of modularity. If we are going to be updating applications this way via the service, we have to have some well-bounded notion of what an application is, what a unit of deployment is, what a unit of update is, and so some notion of modularity is useful. And sadly, the tradition that supports this, the languages that are really strong on this point, are very weak on this point, but they're also very weak on this point. But they have the fundamentals so that you can fix that. So we want our modules to cover both development and deployment. In a lot of systems, there are completely different notions of what those things mean. And so what do we mean by a module? We mean something that is a self-contained parametric namespace. We don't want anything with imports in the traditional sense. What imports do for you in the best case, in the original case, in the modular languages at least, they localize couplings. They never do anything in terms of decoupling things. They just say, I am dependent and forever stuck with this other thing. But at least I have a point where you can see that. Now in a language like Java, they don't do even that because all imports are just an aliasing mechanism. They just shorten names. Right? Because you can use the global name without importing it. So you look at the top of the file and you say, it imports this and this and this. And it tells you very little about what it actually is dependent on. Because it could be dependent on 20 other things that just aren't listed there. And in any case, that's not good enough. We want to decouple things. Right? We want things that are like hardware modules. Right? Like this machine here. You can unplug it and take it away. The analog of an import is a nuclear power station at the other end of this cable. Right? If you actually had an import on the power here, then when I picked up this machine, I'd keep pulling on all this. I don't want to pull too hard because something bad will happen. And out the other end will come a power station. And I'll have to lug that power station with me and take it on the plane back home and so forth. Right? This isn't modularity. Hardware, physics keeps engineers honest. Software engineers can invent things that make no sense whatsoever. So imports are, again, one of those things I really love to hate. So here, of course, all the external dependencies, well, in some sense, technically, there are no dependencies. It has no dependencies. Everything's a parameter, right? But when you instantiate it, it will be dependent on some things, and they're all external parameters. And, of course, it'll export in some way things. So how do we actually realize this? In Newspeak, the top-level classes are modules. So the whole modularity scheme is based exclusively on classes. There are no packages, no units, no templates, no anything else. Right? A top-level class is your module. And this works because there's no global namespace. So if it's a top-level class, it doesn't really depend on anything else. It can't. There is no way for it to refer to anything else. In Newspeak, all names are late-bound. As a first approximation, ignoring actors and stuff, you can assume that every name refers to a virtual method call. I've given like 4 talks on Newspeak here at Microsoft alone, so I'm hoping that some people have heard at least some of them. But what that means in particular is that class names are also done through method accessors effectively, which means that the classes have to be first-class objects, right? Which means that in this case, the module declarations, the top-level classes, are also first-class objects, which can be stored and treated as objects, and in particular synchronized via this synchronization scheme. And they again, since they're classes, they can be instantiated into objects, and you can have multiple copies of a library or something done that way. And anyone who wants to know more should look at some of the Newspeak talks. But the parameters to a class, the way it's actually instantiated is by invoking a factory method on it. There's no constructors, there's only factory methods. And they're built in. You don't have to do something explicit with them. And the result of that is that the only connection an instance of a top-level class has to the rest of the world is through the parameters to that factory method. Because there is no global namespace, remember, it can't actually see anything else. It can't refer to anything outside that definition. And so the only way it gets connected to the world is by virtue of those objects that are passed as arguments. So those objects are capabilities. And those parameters to the factory define a per module instance sandbox. So you can see how the language and the capability model just work together. Particular applications, the things we want to deploy on the service, they are objects. And therefore, deployment is basically, again, taken care of by object synchronization, which is what we wanted all along, right? And in the scenarios where since we don't actually have this service yet, it means that, for example, serializing an object is a serialized object. If you have an application object, you serialize it, you have essentially a binary, and you can deserialize it and load it. So again, we cover a lot of ground with very basic mechanisms. And that's actually something I can demo if anyone wants to see. So what does this look like? This is, well, the syntax is no commitments as to where the syntax will end. But this is something that hopefully for the most part you can read, except the interesting part. Gee, I had this laser pointer. What did I do with it? One hopes. Well, there's a finite number of pockets. Yeah, well, it's okay. I really want to use my laser pointer at least once. Right? So here, it's fashionable nowadays to call computer stuff magical and wonderful. And so we have this class. Now the thing that you can't really read, this is the body of the class, which is, whatever's in there doesn't matter. And what you can't really read unless you know Smalltalk or some language like that, or Self, or Newspeak, is this thing, right? That is basically a method header. It's a method header, just the header of a method with two arguments, p and args. Those two that is the header of the factory method. The declaration here will evaluate to a class object, which will have a method called platform::args::. That takes two arguments. And that is the factory method. So you can invoke it to create an instance. You take that class object that is a result of this, you call this method, and you pass it arguments. Since it is a top-level class, there is the code and the stuff in here, whatever it is, can't see anything in the rest of the world. There's no global namespace. So its only connection is these two guys. These define your sandbox. Right, so that's a basic way it works. Here we have, I don't know, well, we'll see later, but I don't necessarily plan to explain in detail how this app structure works. But the important part is that an instance of this guy will be an application, right? And so when we have such an instance, we can serialize it by ordinary object serialization. And because it is a top-level class with no external dependencies, we will not get megabytes of stuff. I can actually show you what an app like this looks like. Someone had a question, I think. Yeah?
So a lot of the use of JavaScript in the web now is sort of incorporating multiple sources of JavaScript into the same web page. So there's multiple independent sort of units that combine. Mm-hmm. So they interact in various ways through the DOM and through the JavaScript global namespace. So would you allow such an interaction in your model, and how would it work? How would you do a mashup, essentially?
So I'd argue that people who are trying to fix JavaScript so that mashups work better are arguing that you shouldn't have a global namespace, right? when you're interacting, presumably in a mashup, you're actually interacting through URLs that are actually bringing stuff in. But the actual program that is the web page per se is not should not be using a global namespace. You need to have a way of putting together such a program, but you don't need a global namespace. You don't even really need that in JavaScript, except that there is one, and the browser API sort of dictate one. I'd argue that there's probably a way to adapt some of this model to JavaScript. JavaScript is one of the few languages that actually is flexible enough that you could take this modularity model and impose it on it without a global namespace. I'd also argue that my goal here is, in fact, to compile this stuff into JavaScript so that you don't need to write JavaScript. And I don't know if that answers your question, but I know that being comfortable in this scenario where you don't have a global namespace is something that is problematic for people, and maybe we'll take the time and actually go through a demo, well, we're doing well on time, and show how that works. And not sure if I've answered that, but that's as much as I want to answer right now. So, what are we doing? We have oodles of time, but we'll do the demo at the end when we're sure we have time. That's the basic concept of these modules, and so the idea here is that you can easily define your application in a modular way where there's an object that's a fairly small object, and we have a mechanism for synchronizing objects, which is how we would actually deploy them over the service. Now, this is where we're about to take off into the wild blue yonder and do the stuff that's really sort of mad scientist stuff, almost. So no versions. What does that mean? So we've got people subscribing to this service, right? And they get bug fixes and updates continuously through the service. I'm not talking about how they got a subscription. Maybe they bought a Magic Phone. Maybe they signed up with Microsoft Azure. It doesn't matter, right? They somehow have this service. Maybe they're paying for it. Maybe it's someone else is paying for it. But ultimately, just like with a web page, there is only one current version at any time. Right? They never have to worry. No, when they call customer support, they are never asked, which version are you using? How do I find that out? Where do I look at that? How do I know? Right? None of that. No one asks you about a web page what version it is. The beauty of this, the question doesn't even arise. Right? So this is very much like that, and we've seen that this tends to work fairly well for applications as such. Right? And so from this, I'll go on and make this rather dubious claim of no releases. Right? So what do I mean by no releases? This is very different from normal software development. Now, for applications, we can sort of see that, right? There's essentially continuous releasing going on all the time. Right? You can dribble this out at any time by updating your page. Right? Of course, internally, you have to test it, whatever, but you're not, and so in some sense you release it when you put it out on the publicly available page, and you can stage that to different geographies and all those kinds of things. But what happens if we really want to apply this idea to libraries? That's where it gets really crazy. Because as long as we had an application, the consumer of that application was a human. And what little good there is to say about humans, they're fairly adaptive, creatures, just like rats and roaches and other successful species. And so they'll cope. If I've changed the damn app and it no longer has a feature, the things will cope. Now, if I do this with libraries, it's just computer programs, nice, predictable, logical things. They're brittle. They can't cope worth a damn. They tend to collapse into rubbles of bits at the slightest provocation. So how are we going to do this, keep changing these things without orderly releases and so forth? So here's my mad scientist scheme. Basically, just as your end users are subscribing to the service for applications, you can imagine a service of pre-release for libraries, right? Of libraries that aren't publicly available yet. But that's what the developer is working with, right? And we expect a very, very compressed change cycle. It depends how big the library is and how many users it has and how complicated the sort of dependency hierarchy worldwide is. But as an intuition, if you have a release of this thing once a year in a conventional model, expect a release once a week, right? It's sort of like builds in open source, right? And the developer who's developing against this library is on this treadmill, where things are changing. All the change is part of life in the wild, and you adapt. Of course, you don't have massive changes because you don't have a year's worth of changes in this new release. You have this week's changes, right? It's adapting to the latest build, and you develop that way. Now, how is this really workable? So from the perspective of the developer of code, someone who's putting out this library, this is a dream come true. Having worked on, in an organization that put out libraries for a long time, perhaps you can see why I'm motivated by this. Essentially, you don't want to necessarily make things incompatible, but you can. In particular, you can take things out. You can change your libraries. Say you want to deprecate a method. Well, okay, deprecating a method is easy. You declare it deprecated. But you actually want to get rid of the damn thing, to really, really get rid of the evil thing. So what do? You announce it's deprecated, and it's going away in 2 weeks' time. And here, by the way, is the script that will, refactor this into a call to the new recommended method that is in our release. And your developer goes and can run this script, or you might get to the position where they actually authorize you to run these scripts automatically on their image of their code that's on the repository in the service, right? And you're done. And 2 weeks later, you take it out because you know the world has moved on, and you don't have this cruft growing inside your applications forever and ever, right? Now there are other scenarios, of course, which are worse than that, but you have a great deal of control here. Essentially, the world is your IDE. All these subscribers to these libraries are in some sort of contractual relationship. And you should be able to do things like find out who's calling what, who's using what. One of the great problems we had in Java, and I suspect here as well, is, there's some piece of random garbage. It's a bug, basically. It was never specified to work in a particular way. But it got out there. And now you don't know if you can even fix. Every compiler bug was essentially an immutable change, right? Because fixing it will break somebody. You have a large user base, and you don't know where they live. And so you can't get at them. Now here you know where they live. You can communicate with them. They're subscribers. You can actually find out what they're doing to some extent. And of course there's privacy issues, legal issues, IP issues, right? There's a lot to be worked out about how these contracts would work, how your relationship with a subscriber here would work. But basically, the world is your IDE. You can find out who's using stuff, and you can refactor them. And you can make mistakes. Now, mistakes happen anyway. You ship releases with mistakes. And if you have a bug in a release, tough luck, because it's going to take, 6 months until the next update, if you're lucky. And if it's a significant bug, it's only going to be in the next release, when you retire. So here, you're likely to have more bugs, but you can fix them really, really fast. And you can get feedback about them really, really fast. You can find out, essentially, when an exception gets thrown anywhere, it can tell you. Question?
So how does that tie back into the object capability model? So if by mistake, you send out a version that gives you far too many capabilities, right? You leak pointers or whatever, and code gets a hold of them. And so client state gets corrupted and gets synced back.
Right.
And then you're like, oh shoot, I need to go fix this. But now the main source, now that you've synced it back, is host.
This is actually one of the best questions I've ever had about this. And so this is, I'm going to have to make up an answer to it, right? So this is, the interesting thing is that this is exactly the weakness in the classic Smalltalk image model, right? Is the beauty of this thing is you have all your state and you can resume it. The downside is sometimes you want to start afresh because you had a bug and it corrupted things, right? So you will need to patch your image, as it were, right? You will need to put out a script on the server that will fix everybody's data, right? Essentially, I mean that's basically, and you can say this is how horrible a problem this is. You can debate that. If you put out a security bug that corrupts your programs in a conventional release model, well, they're out there corrupt and doing things. A security bug is a serious issue, right? And I'd argue you at least have more of an opportunity to fix it than you did otherwise. But touche, that's one of the best nasty questions I've ever had. on this. Yeah.
So I'm curious how this approach relates to standards. And so I'm thinking of the following. So people can change their APIs, and in particular, companies are known to have APIs that are specific to that company, so that you're locked into their software. Okay.
You think.
So the flip side is that the standards process is a slow process that is a deliberative process that decides this is what's standard and this is this isn't standard. So it seems like these are they work against each other in your model, because you're saying things should change rapidly, right? Yeah.
So they do change rapidly. That doesn't necessarily mean that you can't sit back in the background and think about how they should be, and what at some point we should come up with a standard, right? We put out this library and it's no good, and these other vendors have a library, and everybody should now conform to the ISO whatever 10,004 standard, right? So then you put out this library that conforms to the ISO 10,004, and you build a migration path, which, depending how different ISO 10,004 is from what you had before, may be more or less difficult or plausible. But you can say that, well, ISO 10,004 calls for things to look this way, and here's how you migrate from that model to the other, and you actually migrate your data, right? You actually say that, and this was probably something. So let's go to this slide for a minute, and maybe these things will relate, right? So before, the first slide was about the easy part, about the producers ramming stuff down the consumer's throat, and that's great fun for the producer. Now, what if you're on the receiving end? That's the more difficult part. But one of the things you can do is, if your libraries are changing, you don't want to actually have to synchronize the actual timing of how these things go out, right? So it may be that there's a new library that does things differently, and you actually have to be aware for some transition period of the differences, right? So you put in conditional code that has to deal with, well, if things are this way, we'll do this, and otherwise we'll do something else, right? And over time, this cruft builds up, right? The nice thing here is, you do this, and you put out your app version that can cope with whatever library that's changing, and how it's going to change in its next whatever micro release in next week. And when that's done and the world is updated, you can get rid of that conditional code and dealing with the old case. You don't have to deal with the 20 old formats that existed, or the conditions, right? Because you can live very close to the present. You don't have to deal with this long history. Now you can also, I would argue, and I said this is blue sky, right? Skepticism is the normal response, right? If you actually have decided to completely, there's this whole new model of the world that's the new standard, what do you tell them now? You tell them, well, okay, maybe I have an offline tool that'll migrate your data. That's one story. Or you can try and do it by hand, or you basically forget about it, use my new tool, and this is how the world is going, and you throw it out, right? If you have a automatic migration path, then you can simply apply it to the data that's out there. If you don't have one, then you've basically told them their old data is useless unless they find a conversion they do themselves, which again is the same thing, right? I don't think this really changes anything in that scenario. You just have more. It's just easier for you to find out who's affected, how much they're affected, and help them, as automatically as possible get through that. You have a lot of freedom to do that. And this is completely sort of on a separate track from the quick, constant, evolution. The fact that the standard takes forever, I don't see that as being an issue here. And again, all of these things, you have the advantage, right? With a web app, one of the beautiful things is the crashes happen on your server, not on the client's thing. So yes, the client still sees a problem, except for the JavaScript bugs, right? So the nice thing here is both the client and the server bugs are accessible to you. Even if if the user was working offline in his igloo in his research station in Antarctica, when they get home, they will sync. And you can arrange it so that they can actually tell you what happened, right? What exceptions happened and so forth. Now there's privacy. This stuff has to be anonymized and scrubbed. There are people doing research on things like this. And there's these cool encryption schemes which can do wonderful things that they can actually take all your data while ensuring that the other guy can't see them, and so forth. So there's interesting problems to be worked out here. But the vision is that it's a service. Yeah?
It would seem like if you break, someone's app, then maybe they can go back and understand how your API changed and fix it. Mm-hmm. But if it went the other way, and you broke like Google search or Bing or webmail.
So there that is an app that's different because
it's different because people, there are contractual obligations to keep the service up almost all the time. And so if you could sort of change APIs and then you know because search breaks.
Right. So there's a couple of things to say about that. Yeah. The more mission critical something is, the more early analysis, static analysis, the more slow and deliberate, all that, you should be. Which means in this case that this is probably something that might go through actually several intermediate stages, right? The release cycle might be 6 weeks, and your own developer cycle. It's like workspaces in development, right? You change things and then you push them up to the group, and wider circles of people are affected, right? And you can do this in different whatever you want to call them, channels of the service, right? So if this is a really big mission critical thing, then obviously you might say that we're not going to push it out until 6 weeks, and this is time for Google to test this or whatever, right? Because it is a mission critical app, and Google still changes it. And if they make a mistake, there are rumors they make mistakes.
But if there's a dependency on something which you don't have control over, so you're
right. So if they find out that there's a library that third-party library they chose to use, they can say we're not going to take the latest version. We're going to keep the old version. It is in the nature of this model that, no, they have to be on their toes. It may take a longer time. You have to determine what the window is, the bigger and more mission critical it is. But basically, what you could always do if you're really desperate, you can clone the whole goddamn thing, right? You can take the set of objects that constitute this library and change them and map and decide that you're using your own fork until later. You could always do that.
You take the power.
Yeah, right.
Yeah.
Clemens.
Yeah, I noticed that you just used the word version.
I know. So obviously.
But I do have a question related to that. So, if you actually anywhere in kind of a mashup composition situation freeze to an earlier version, basically just an earlier sync point, I guess, then transitively you expose the world to versions.
Because you have explicitly made a copy or a fork, and now you have this thing. Except that it's your problem as the user.
Well, but the transitive problem is everybody's problem, right?
The transitive. Okay, so if you tell people that that we're using which is why this is not a recommended thing to do, and it is your problem in the sense that you're the bad guy. You're the guy it's not the developer of the library who is putting out umpteen versions, right? You have failed to keep up with the timeline as it moves, right? And so you have.
But that is the nature of versions, right? There's always the latest version, so you can always go and say the guy who makes the.
Well, so part of this is a cultural change, right? You need to actually make this work. There's a lot of work to be done, and part of it would be to find the group of crazy early adopters who are willing to try this out, right? And play with it and see how it really works out. And this is like open source is a different culture. This is a culture where the expectation is you keep up. If you decide to fork something, then you have essentially a different library. And if you actually expose that to other people, you have again typing makes this worse. By the way, it's much better without typing because then as long as you can maintain an API, you're reasonably good. Once you start having nominal type systems involved here, I don't claim that would necessarily work because that's far too rigid. But the idea here is that you don't want to do that fork, right? If you're absolutely desperate, something bad has really happened, one might do that, but I'm arguing that isn't the recommended solution. The recommended approach, the general idea here is you keep up with things. You just will fix your thing to make it. And sometimes you need a larger timeline, but they won't change that much, right? You keep these things in proportion, right? Because it's changed, if you have an update every week, it isn't like an update that came after 2 years. You don't have as much adaptation. Now, sometimes there are major structural adaptations, and maybe you are forced to do them in bits, right? Just as you might do actually during development in a Smalltalk like IDE. Sometimes you actually have to get there in steps. I don't know if you have the intuition for what I'm trying to say. So definitely, I know this is the controversial part, right? Up to the point of applications as a service, this is already happening, right? The first version of this talk that I gave publicly was in 4.5 years ago, and I was thinking about it for a good while before that. Ever since I started using basically Google Mail, Gmail, that's when it hit me that we need something better, right? So the issues are still out there, but a lot of this is happening, right? You look at things like the iPad and what its significance is, and the App Store, and this idea of a service is happening, at least for applications. For libraries, I know I'm crazy. That's fine. I think some research has to be that way. So, to try and capture the big picture here, we talked about how object encapsulation is useful for our security model, why dynamic typing and security are useful for hot swapping, how this is supposed to enable software services, and if you take software services very seriously, almost insanely so, then you get into this utopian or dystopian, you decide, world of version-free software. A little bit about related work. And
can you go back
yeah.
just the
Sure.
slide just for a second? So in this discussion, hot swapping is pretty central, right? It's
right.
sort of the building block that requires these things and enables these other things.
Right.
And so my question is I see hot swapping as kind of an issue of granularity. So hot swapping says I don't have to stop the program; I can update on the fly. Whereas the current web model, really, you get sort of hot swapping, but you have to restart the program. You basically have to reload the web page. Now, from a user's point of view, that actually may not even be perceived as a restart in some sense. It's a reload. But in fact, it's less fine-grained, but it gives you many of the qualities that your hot swapping gives you. So my question is, if you back off of hot swapping and say page reload is the unit of granularity, how much do you lose, and how does it change your overall structure?
So page reload. So number one, the analog of restarting on a web page, in my view, is session expired. Right? It isn't there for you always. It's there for you for as long as because the burden is on the service to keep this connection alive. They want to get rid of it. They don't want you to walk off in the evening and come back in the morning and continue your work. So as long as web pages are selling you, movie tickets, transactions of that order, that's kind of reasonable. When all applications are delivered this way, when this is your design session in Photoshop with your catalog that you've been working on for 3 months, you do not want to necessarily restart it, because even today on a local app, it's a hog and it takes forever to restart, right? You don't want to. You also don't want to be so burdened with worrying about what happens to it. If it crashes, if my network connection goes, what happens to all these things? So I'd say that in those cases, the page model does. That's one problem with this thing, is that these sessions don't last unless you're actually there, keeping them alive. The other problem with the page model is page. I'm not interested in pages. What Ajax did for the web world is that essentially you can have an app in a page and it continues to interact, and this whole refresh is not something you see. It's all going behind the scenes, right? So the notion of page doesn't strike me as necessarily very meaningful here, right? Let me be a
little more clear. So when I said page reload, what I meant was if I'm in Gmail, I can sit in Gmail for a day or 2 or 5 and not have the code change at all. It's basically a version of Gmail.
Right.
If I hit refresh and I reload the page, new JavaScript gets brought down. I can have a totally different version of Gmail at that point. Okay, but it's quick, it's fast in the sense that I don't really perceive it as a big, penalty in some sense from a user's point of view, but it gives you all the capabilities of your hot swapping. It essentially allows you to update all the software that's in that application quickly, essentially.
Right. So this works for an application where it's essentially all the code comes in this page, and it can do that in a reasonable time, and it doesn't have a large amount of data that it has to update. And we've discussed actually ideas of lazy update of the data, so that might help with that, right? But lazy update of the data brings up a lot of the hot swapping issues as well, because these are actually objects in memory. So I'm not positive I buy this. There probably is an engineering. There is a whole path that probably avoids hot swapping, at some cost that the public may or may not be happy with. In particular, the public doesn't know any. If it doesn't know any better, it'll assume this is the way. So I cannot, in good faith, argue that the world will necessarily be doing hot swapping. I'd argue that it's a really nice way of doing this, because it really gives you a coherent way of dealing both with upsyncing your data and your program. So if you don't buy that, and you can certainly make your life simpler by saying, yes, we essentially restart this by essentially loading all the code of the application afresh. And the question is, how do I get to the place I was, right? So with Gmail, we know where I am. You're showing me my inbox or something. They must maintain, or the page actually tells you what state there is. There isn't all that much state, right? The state is which page I'm showing, and all the rest is data that's fixed on the server. If I have an interactive application, which windows are open. If you don't want to shove all that data every time, then they're really. I'm not sure this works for everything, right? But certainly there are other approaches one can take. And yeah, you're right. If I don't need, I need security, whatever, I'd argue, right? And I think, and I like object capability security for various reasons. Dynamic typing, sure. If you took out hot swapping, would I still do these things? I personally still would for other reasons, right? But certainly in this scenario, this is what's driving things, and you could imagine a different design. Lots of related work. I mentioned the UPSLA paper. There's a bunch of mirror systems that have been used in different places. No static. Well, Scala itself lets you do programs with no static, except the objects the top level objects are kind of static, and because it's so tightly integrated with Java, static stuff is always there. I think Fortress is doing work on this. E, which is a security-based language that Mark Miller did, which, again, pioneered the object capability model and has been also significant influence on the Newspeak language work. Self is the most significant one, and Smalltalk, and then Beta, and E is becoming increasingly more significant as we start to look at that concurrency and actors and stuff. What else? Yeah, modularity. There's infinite work. Actually, the ECU paper that will be in June, which you can all find this on my website if you're really interested, spends arguably too much real estate on related work, and will cover this whole world. But the closest thing in terms of this scoping model is probably scheme, PLT scheme with the units. You can see this parametricity. You can see something similar in ML, except it doesn't really work because of, well, that's a whole talk as to why it doesn't work. Fortress also has sort of a component model that's kind of related. We didn't really talk about representation independence. There's an endless world of commercial stuff and other things. So basically, the summary is that because software is becoming a service and not an artifact, then how our platforms are changing and how we program might change in perhaps deeper ways than you might think. And the issues of reflectivity or dynamicity or whatever you want to call it, and security and modularity are all programming language issues. That is, sure, in the end you might do it in the messy world with whatever you have, but it is going to be not as effective, much more work, and certainly to explore the issues, I'd argue you want to do it in a cleaner framework. And that's what Newspeak is. So that's the talk. And if anyone wants to understand Newspeak better or has specific questions about how this stuff looks and so forth, I could do some more. But this is what this talk is about.
Thank you.